Yeah, let's go and factor this one now. On the surface, we would look at this problem and say, well, let's go and group these together and factor out an x, and you get x minus 10 there. And then you'd probably say, well, let's go and factor out something from this, this grouping right here, but there is nothing to factor out right there, which is problematic, right? Because in this type of factoring by grouping, how we have this binomial x minus 10, that means over here after factoring something out, we would need something like x minus 10, which is going to be very difficult to force if we have a y squared in the second term, which needs to be factored out where this one doesn't have any y's to factor out. So this is once we see this, we would usually declare this to be not factorable, or just say that it can't be factored, but it can. And this is where it takes a little bit more creativity here. We got to look at this a little differently. So what we would want to do is take our time and think about this, right? Like I've got the 36y squared. That's meaningful right there. What I notice about that is that that would be something like 6y that would be squared right there. What I also notice is the 25. So this right here, it looks like it's going to be a perfect square trinomial, meaning that I should be able to take it and square something. It should be some kind of binomial that's squared like this, okay? So, okay, well, what does that mean? Well, let's go ahead and look at x squared minus 10x plus 25. So I am kind of grouping. I'm just grouping it slightly different. What I need is two factors of 25 that add up to negative 10. So we'd say the coefficient of x squared is 1, a phantom 1. So really, maybe you're looking at, maybe you don't notice that that's a perfect square trinomial, but if that's the case, then you're going to have some x's here and x's there. Okay, well, what is the numbers that go there? Well, what two numbers that are factors of 25 that add up to negative 10 here? As it turns out, it's negative 5 and negative 5. So then we'd get negative 5 there and negative 5 there. And by this time, hopefully we can see that that is actually x minus 5 squared. Okay, now we still got the 6y squared as well. And then we do have subtraction between these, right? So what I have right here is the difference of squares. So up here at the top, we had a perfect square trinomial. And now right here, we have a difference of squares. So we are expecting two binomials, one with subtraction, one with addition. We just got to figure out what the a and b are, but that's what this is right here. So we got, for example, the first set in this parentheses, that would be kind of like our a right there. So let me see if I can set this up here. So we got, again, they're going to be two binomials, one with subtraction, one with addition. But the first value is actually that x minus 5 right there. So I'm going to put in parentheses, although in the future I'm going to get rid of those. And then, again, it's the first term in both binomials. And then we can see the 6y is the second part right there. So we end up with something like this. Now that I have that, though, let's go and clean that up. And we end up with something like this. But this is it. Okay, so you can look at all three terms in both of these, even though it was a binomial. But now we have three terms in each. So they're kind of trinomial stuff here. But I don't see any like terms that I can combine in either one of these. And you could say, well, what would happen if we were to distribute all this stuff? You'd end up with the same exact expression that we started with. And that's a good way to check. But again, our purpose there was to factor the original expression, so this is what we end up with.